Hello guys, welcome to the Java course. Unfortunately, me, Andrew, and Eric can't be making it to tomorrow's class. Well, I guess it would be today's class. No, never mind. Tomorrow's class. Uh, it might be going on the day of this video. Yeah, just the next class at a 3 to 5. We're all out of town or just have some things to do. Um, and yeah, it's a unfortunate coincidence, but yeah, uh, there's not much that can happen that we can do to change it. Instead, we're gonna be putting up an example video, which this is, in place of the class. But yeah, I just have a couple of announcements. Um, so we were wondering if over the school year we would shift from a continue doing a Java class for free that's posted on YouTube, or at least this is something that I was considering. But instead of doing some sort of like instructional thing like we're doing right now, we're gonna do some more like devlog type of thing. Basically, just we're coding something like a project that we're personally working on, and we're gonna log it for you, and we're gonna discuss like how each things work, and it's gonna be like a behind the scenes where nothing's planned out. We're gonna go through like debugging, if things happen and stuff like that, and just give you regular updates on our projects. Um, Obviously, like the project's gonna change. Like we might have. It depends on like what I'm personally wanting to work on, and then Eric and Andrew might be interested in some other things, maybe different languages. It really depends. But yeah, just something like that. Just releasing regular content over the school year. Obviously, it's gonna be a lot harder to do like actual full form content and instructional content like what we've done over the summer. We've kind of been struggling to keep up with everything. Um, Even now, so when we have like a bunch of homework to do and like classes most of the time where we can't write out lessons, it'll be a lot harder. Um, but yeah, uh, getting that out of the way, I guess we're going to start off with some review. So last class we actually covered quite a lot of content. It was more than I was expecting, which is why the last half of the class there wasn't any slides. Um, we were just planning to cover like arrays and then maybe functions, possibly, but we got through a lot. So why don't we review that? All right, so starting off with arrays. Arrays are like sets of items, so we can have something like this. One, two, three, four, five. This is called set notation right here. Um, this is a just type of mathematical notation to show what's in a group of things, right? So usually in math you contain numbers, but in coding we can contain a bunch of different data types like strings, like ints, like chars, stuff like that. But a couple of rules are it has to be the same throughout the array, the same data type, right? So it has to be either a string when you make a string array, an int when you make an int array, and so on and so forth. And also, once you make the array, you cannot change the size or data type. Um, so how arrays are calculated is each value gets an index. So if we have like, let's say we have a string array of like cat, apple, uh, car. And let's make it a bit bigger as well. Cat, apple, car, and I guess we could also include uh, desk. So this array is going to have, oops, my tabbing is a bit off here. This array is going to have an index assigned to each value. So the first value will have index 0, then 1, then 2, then 3. So indexing, all the indexes start at 0, array indices start at 0, and it goes up 1, 2, 3. Uh, And this is the case. I mean, it really is just arbitrary. In an alternate universe, maybe arrays start at index one, or maybe index two. I mean, it's really just arbitrary. But this is basically the same in virtually every single coding language that you find. It's one of the few things that's standard across all coding languages. Uh, so yeah, um, we can also so the array size can't be changed, but you can also just unassign values from it. Like, for example, if this isn't a real array, oh, I clicked something. I bookmarked this. There you go. Um, so, yeah, Let's take a look. So this is an actual array, but this is just comments, like so we can understand and see like what's inside the array. You're not gonna be able to see everything inside the array when you actually write it out in Java. But we can see here, we can delete this, and this will get replaced by null, which is the universal placeholder for no value. We discussed this in class last time. Uh, but yeah, so this is basically it for the theory behind arrays. But so let's go and take a look at how to write them. So we're in our main method here. Just remember all code has to go in the main method unless it has to go in a class in Java. This isn't the same for other coding languages, but has to go in a class in Java and also has to be in a method. And the method that gets run when you run your Java code is called the main method. So the main method's public static void main string args, and all code goes in here. So to type an array, oops, seems the computer's lagging. There we go. So in brackets, this is the data type, right? When we're making like a variable, like in x equals 3, this is the data type right here. Same thing for this. It's int, but it's brackets. Square brackets is to signify the array. So I call this int array. R is just abbreviated for array equals new int, and we could give it a size in here, like size 3. So yeah, this is the signifier. This is the identifier for int arrays. It's just int square brackets. And then this is the name, but something different from like this to this is we actually have the new. This is used when creating an object, and we'll see objects and classes. But objects are kind of like next level data types. So you have your primitives like int, string, or sorry, int, char, boolean, float, stuff like that. And then we have our objects, which are more advanced. They can have like functions attached to them, which we'll also touch on later. For example, with string, uh, you'll have this. You'll have something like system dot out dot println. We could do something like s dot equals y. So yeah, we have the dot equals function, which just compares the two strings. You can have something like s dots. Well, let's see, we could do clear and comb, and then we can have this. Actually, we'll demonstrate this. This will print out something. This will print out either true or false based off of if the two strings are equal. Let's see. Yeah, it prints out false. Let's just expand the compiler a bit. Right. All right. We can also do something like s dot substring. Let's do something like 3. Oops. And then if we see here, we run it, it'll print out AR. What this does is it just cuts it at the third value and then goes on onward. So 1, 2, 3 cuts here, and then the fourth and fifth value are printed. So AR. And if we do something like y.substring 3, we get b because 0, 1, 2, 3 takes it. And we can actually, there's different syntax here. We could do something like 0, comma 3. This will take from the 0 to the third. You can see now it takes COM. So yeah, there are different things. You can't do this with ints, by the way, or any other primitive data type because they only have like the basic operations, equals equals, and the logic gates. Whereas you could write your own custom scripts for objects, and strings are a type of object. So if we just get rid of this, you can see we're creating a new int array of size 3. This in here is just the size. You can see, yeah, it's just syntax. Let's make this actually a bit bigger, 10. There's also another way we can create int arrays. We could do int array2 equals curly brackets, so like 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5 we should do. So that our index matches up with our int. It could do this. This just auto-populates the array for you, so the array will be like this, or you can have an unpopulated array like this. Alright, so let's just grab our populated array. Let's change this around, get rid of this. Let's also make this all even numbers, so 2, 4, 6, 8, 10. Alright, so to loop through an array, what we need to do is have a for loop. Or a while loop is fine, but I like for loops better. And I equals 0. I is usually the default signifier for a for loop. Again, it's just another weird coding tradition, but people like it if you use I. Oops. There we go. Oh, it seems like I'm typing random stuff in here. Alright, so what this will do is it'll loop through the entire array where I is the index. Well, I guess in this case you could say I stands for index. It really doesn't, because like if we're gonna do a regular for loop like this, where we're not looping through an array, we'd still use I. But I guess in this case you could kind of say that. So it loops through the index of the array, which is important, not the actual number. And then it will do something for every value in the array because it's looping through how many indexes it has, which is just how long it is. So for every value in the array, you can have it do something, which is what you specify in here. We could have it do like system.out.println array of I. Remember, you have to access the array by the index. If you try to print out the entire array, you're just going to get the memory address, right? If we say we do this, you can see we're just going to get the memory address of the array in your RAM. Whereas if we do this, we'll actually get the numbers out. Yeah, so having the name of the array in and then square brackets, and then with the number of the index you want to access, will just return the it will return the actual value of the array or the content of that index. So, yeah, that's really it for arrays. You could fill them with different things, like for example, we could fill it with strings, which are an object, by doing string array, something like cat, oops, dog, mouse, rabbit, snake, and fish. Let's see, this is 1, 2, 3, 4, 5, 6. 6 values. We could call this like the array like pets or something like that. And then we can say something like let's see, we could do something like scanner s equals new scanner. How do you even use the scanner class? I don't really use this. I think we have to do something like system.in. System.in. There we go. So this will give it a source, and then we can do like s.next line. We'll do something like string, or sorry, int in choice equals s.next line dot parse int. Is that a thing? It's not a thing. I think we have to do something like this. Parse int. No, this is also not a thing. Let's see. This will. Yeah, alright. So this should This should return something. Let's just do this. And then choice dot parse. Oh, is it? Oh, it's to int, I think, right? Is it? Is parsing even a function? I'm getting coding languages. Let's look. Parse int Java. Ah, it is a method. It doesn't take in strings. That's a bit weird. Let's see. And oh, I know why. Wait, we should do something like. Hold up. Int c equals parse int of like 3. That's not even a thing. Wait, hold up. Did they get rid of it in the Java update? No way. No way. Java 8. Method summary. Let's grab part. Oh, it's integer. No, 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 nope. Hold up. This just isn't a thing in Java anymore. Here, hold up. Alt Shift Enter. Let's see. Wow. Let's see if we could do this. This is how debugging works. Something just it just doesn't exist. Do you need a? Oh, you might need to put it in a try catch statement. Hold on. Try. We're learning something new today, guys. It's catch exception e in s equals parse int. No, why not? Let's see. Cannot resolve method parse int. Cannot resolve method parse int. Oh, it's linked to the integer class. That's right. All right. So this is a bit of a okay. This is a bit of a weird one. Um, so all right, let's explain what I just did. So I was having a bit of trouble with the parseInt because parseInt isn't actually a function native to int. Remember what we said about ints not having any method of functions attached to them, which are like these things, right? They don't have dot equals. They only have like the plus minus, plus plus, all the logic gates and equals equals. Well, that means that you can't parse int because parse int isn't something that you can turn into an int. It's not something that's related to an int, so you can't run a parse function with an int. So what integer is with a capital I is this is a wrapper class. What this does is it basically takes the int and then it turns it into a class um, such that we can write methods for it. And it has a bunch of different methods attached to it that give it more functionality. So yeah, what parseInt does is it just turns a integer into a string. Um, or sorry, a string into an integer. So if you give it something like 3, it will turn it into 3. And then what this try catch statement is try catch just means it will try whatever code it does in here, and then it will if it has an error, it will print it out. Or actually, you can run it here. If it has an error, it'll run this code. And you can do something like system.out.println e. Oops, right here. And so if we could deliberately give it like a bad input like this, where this isn't an integer, right? So it can't turn it into an integer because this is just a collection of characters. It's not actually a number. So it'll give us an error when we run this. If we actually write this correctly, this should give us an error. There we go. So java.lang.number format exception for input string RA. So usually what this would do is to just crash or just terminate the process um, once it runs into an error. Like if we just get rid of this try catch statement right here, and we try to run it again, it will throw an error, right? And it'll just auto terminate process with exit code 1. But if we put the try catch statement back, it keeps running the code. Um, Even though it just skips over, it just doesn't do this if it has an error. This is really useful for something like games where if you have like maybe just a small or like websites or just anything you want to run continuously, even like just apps, because like if you have a small bug, you don't want the entire thing to crash. Like if we go to some place like Google Chrome, this is written in JavaScript, so it functions slightly differently, but it's basically the same thing. If we actually Google Chrome is written pretty well. Hold up, let's go to something like I don't know what's the site that people go to? Cool Math Games, cool, or let's go to Cool Math Games if that's still yeah okay. And then we run our inspect element, we can see it's throwing a bunch of errors right here. But these aren't errors that like are gonna end the site, right? Like register advertise ad server was referenced but was never created. This is because to get the ads right here, it's gonna call on Google Ad Services, but before it connected to Google Ad Services, it tried to get an ad. It tried to pull an ad from Google Ad Services, but it didn't exist because it didn't connect yet, right? So it's throwing all these warnings and errors like this right here. It's trying to get something from, oops, well, I just submitted a push request, but you're seeing it's trying to get something from places that didn't contain the information, and it's throwing errors. These errors don't actually end the code, right? Like if you don't have an ad on your page, no problem. Um, that's not something that you should crash the page for. So you don't want the page, you don't want like these pages to crash. You don't want Minecraft to crash whenever there's a tiny error. And these things will just allow you to, it'll display something's wrong, but it'll keep running, which is really useful. So why don't we actually just hook this up with this? Oops. We should just keep this. Instead, we're gonna system that out to print line choi. Oops. I also did something. There we go. We're gonna do this. And then what we're gonna do up here is we are going to. All right. Over here, actually no, we should do it under the new scanner. We're gonna say system.out.print. Ooh, we should actually loop this. So for in I equals 0, we're getting a bit off track here, but whatever, it doesn't matter. I is less than pets.length I plus plus system.out.println quotes plus I plus 1 plus a colon space plus pets of I plus actually no, we're already making a new line. We're doing a print line. All right. So now capitalize that. My bad. All right. Oh, actually, this is not good. Here, if we get rid of this, it should work. Yeah, there we go. All right. So what the error we had before was that I added a quote before this, so it was literally it turned this entire thing into a string literal, basically meaning I'm literally adding I to 1 to make like if I was 0, I added 1 to the end of it to make 0 1 and then like 1 1 and then 2 1 and then 3 1 and so on and so forth. But I just got rid of those, so now it's gonna add these two. It's gonna say, okay, I think I'm supposed to add here, meaning like integer add, and then it says, oh, I have string, so I'm gonna string add, and I have another string here, so I'm gonna string add. All right, so we have a text box here. It's just or like an input field. We're gonna make it so that you can input which is your favorite pet, and then output it again. So let's say we're gonna implement this. Why don't we introduce you to another part of Java? So below here, um, we're gonna say I'm trying to see if yeah, you know, mm, let's see. Uh, we could do a switch statement. Yeah, let's do a switch statement. Uh, Let us do a switch statement. All right. Um, so what a switch statement does, this is so like if we were going to normally do this, we do something like if what was it? C equals 1. Oh, hold up. Here. This is a bit yeah, because we're doing this in a try-catch statement. So in C here. So what this is, so the error that we're getting before was that I'm making C in the try-catch statement. So I can't access it from the outside because that's just a Java thing. We could just make it like public. Actually, we could just do this. Hold up. This is a lot better. Public. There we go. Ooh, actually, it's yelling at me. Oh, I'm not. Okay, whatever. I'm not allowed to do it. Whatever. Sudo int C. There we go. So we would do something like this. If C equals 1, then say, then system dot y. We're supposed to Alright, we're just going to say C is 0 by default. And then we're going to say like 0 system dot out dot print line error. So this is going to be our, it should never be 0. And then if elif, or sorry, else if C is equal to 1, then we're gonna do system dot out dot print line your favorite animal is a cat. And then we just keep doing this. I'm messing up. Hold up. Sorry, I put my keys on wrong last night. If else C equals 2, system dot out dot. We could do this, right? This is something we could do, but this is a hassle and it's also not very efficient. So another thing we could do is let's first go to this. We could do something called a switch statement. So what this does is, hold up. Yeah. So a switch statement is like just basically a chain of if statements, right? So how we're gonna write this is we have switch, we have the variable we're gonna put in. I think it has to be an int. I don't know if it works with strings, but we're gonna do case, and then this. So case and the value you want. No parentheses, no whatever. That's a bit weird. I wish it has parentheses because then it'd be a lot clearer. But yeah. And then like in this case, if it's value 0, then we're gonna do this. We're gonna do system dot out dot print line error. And you quotes around this, right? And then we're gonna do something. We're gonna do a break, just saying this is the end. Stop here, and then we're gonna do the next case. Hold up, my tabbing's a bit off. Case 1, system dot out dot print line. Hold on, I'm just gonna make a template so I can copy paste this. Here we go. We're gonna do your favorite animal is a cat. Here we go, and then Yeah, it's a bit buggy with these. The tabbing. Dog. Actually, I should just do this. Your favorite animal is and then I could just write it in all convenient like this. Gosh, IntelliJ. The tabbing on this is really infuriating. It doesn't really matter. Tabbing in Java doesn't matter like it does in Python, but it just makes everything look so much better. Your favorite animal is a mouse? We said mouse. Break. And then, obviously this is also isn't ideal. There are better ways you could do this, like just comparing it to the array itself. Actually, yeah, but okay. So now you know how switch statements work, which is what I kind of wanted to do. We can also just do this. System dot out dot print line. Your favorite animal is, I need quotes. Your favorite animal is plus pets of C minus 1. Let's also put this in the try catch statement, just so that in case someone puts in 0, like a little cheeky boy, we'll throw an exception in their face. We're going to do an array out of bounds exception. Alright, we're going to stop this rerun. Line 20. Do we have an extra? I think we do. Yeah. Alright. So if we put something like 6 in, your favorite animal is a fish. Let's go. Alright, we spent way too much time on this, but I guess this is just how live coding demos work. They always get out of hand. Okay. Let's make, you know what? Let's code a little, let's do a little coding. Alright. Uh so functions are something that we've kind of alluded to before a couple of times, but we haven't gone in depth. Well, we did in last class, but this is review, so we're gonna pretend like we didn't. So functions are basically just code that you can execute more than once, right? Think of them like little factories. You have an input that you can put in, and then you get an output. And then on the inside of the function is basically what just happens is the machinery, right? It's what you do to modify the input into the output. Some functions don't have input, they just make the same thing over and over again. Some functions might have inputs in different ways, like they might just get the date and then make a different output on that instead of having the input done correctly through the correct channels. Um, uh, Stuff like that. But in most cases, the input of the function will be written like this. So you have we're going to have to write it outside of here. Let's see. This is the class, this is the method. Okay. So, tabbing today. Damn, IntelliJ. Not good, not good. Okay, so we're going to do something like public. No, we're not static. Public, I don't know. Let's have it return an int. Int or sorry, boolean, boolean divisible factor of 3. Factor of 3? Is that how the math goes? What is a fact? I don't know. That might be how the math goes. I don't know. It's not like I'm in UB math or anything. I should know this, but whatever. Yeah, we need a return statement. Return true for now. That's just placeholder, just so I don't get yelled at by my code. All right. And then it's going to take in here in the parentheses is where we have the. All right, I forgot to tell you. Public just means that anyone can access this no matter where they are. In like the code, you might have different files here. They can access it from there. Boolean is the return factor, so we can make this an int, and it'll give me an error because I'm not returning an int. So this is the output. Return just means output. And each time you run a function, you can only have one output. Remember that. So, yeah, this is the output type. It can only be one kind because, like, if you, for example, want to hook a function in your code that like sometimes spat out strings and sometimes spat out ints, and like, this is designed for like teams of people, right? Like maybe your coworker Jeff is writing the function and you're just implementing it into your game. Like, maybe it's returning like you're playing Minecraft, you're coding Minecraft, and it's returning the type of block that you're looking at. Well, if your function sometimes return like the ID of the block, and sometimes return the block name, well, you couldn't code off of that very well, would you? Because you're not getting a consistent output. You're not even getting a consistent type of output. You couldn't process that data very well. You have to write two different systems for that. That'd be really inconvenient. That'd be really just, you know. So this is a like a kind of thing to make sure they are consistent with your functions. Obviously, other languages don't have this. I know JavaScript just doesn't have this at all. Um, in JavaScript, half the time, like you just don't even have to have correct syntax and it's still run. It's kind of crazy. Um, but no, this is a strong type language. JavaScript is a not strong type language. This is a strong type language, which means everything has to be consistent. Uh, so, I accidentally did something. All right, so we're gonna have an input here, in the parentheses. We're gonna have an int I. You don't even have to do any value, provide any value, because actually let's do an int x, because the value will be provided by the user, right? That's the input. You just have to name it and you give it a data type, so you can reference it in your code. So here, you know what? Let's just have like an int test int input, whatever. Uh, oh, this is very simple. There's a couple ways to do this. We can do something like boolean out equals input modulo 3. This is not good. Oh, right, it can't be a boolean. It has to be a... Hold up, we can do this. If input modulo 3 equals 0, then return true, and then out here we can do return false. Alright, so what this percent sign is, it's modulo. You might have heard it when I was talking to myself, but modulo just it says we are going to have the number and then we're going to divide it by 3, and whatever is left over is what we're going to output. So for example, if we had 16 modulo 3, we'd have 1, because 16 goes evenly into 3 5 times, and you have 1 left over, right? Because you have 15 and you have 1 left over. If we had, like, for example, 5 modulo 3, that'd be 2, because 3 goes into 5 once, evenly, and you have 2 left over, and the leftover is what we're looking for. If you have a leftover of 0, that means that your number is divisible by 3. Oh, that should be what I'd be writing. Divisible by 3. If you have modulo of 0, if you have any other number of modulo, that just means it can't be cleanly divided by 3. It has some leftovers. So we're going to return true here. We can write return false out here, because when you run a return function, your function automatically terminates. It's donezo. There's nothing more. It just terminates itself. So if we have like this above here, it'll run this first, and if it doesn't run, then we can assume it hasn't terminated. So we can assume that it's not true. So we can just return false out here. This just saves you the hassle of writing another else statement. And then if it is true, if it's clearly divided by 3, then it will terminate itself right here. It will never get to this line. So that's why it allows us to do that. System.out.println. Let's do something like divisible by 3 of 3. I need a static keyword here. I think it's something they have to put in I think standalone functions and also in your main class. I'm not sure what it means, but like here, I can actually look it up because this is what coders do. They look things up. What does this mean? Right. So it's because this is the main class. So when you write functions which in other classes that are supposed to be instantiated or made into objects, like for example the functions in like the dot equals in the string function, right? Which we'll get to later. Those are instantiated when you make a string function. So you don't have to give static, but the main class is never instantiated, so you need to give it static because it's standalone. It's not attached to another class. Well, it is attached to the main class, but it's never instantiated, so it's effectively not attached to any other class. So we're gonna need to give it the static keyword. That's why we have public static void main, right? Also, I forgot to mention, well, this works, but void just means it's not returning anything. So if you want your function to not return anything, give it void. I'm pretty sure we could swap the order of these around, right? Can we? I've never heard of anyone that does public boolean static. Oh no, we can't. Yeah, okay. All right. So now it's time for classes. Classes are gonna be fun. Fun times. Okay, let's go into a new file because that's usually what happens. You have one file per class in Java, and actually when you make the file, it's called a Java class because everything's coded in classes. Let's make a player class in a game. Capitalized. It's like calculus. Like if you want to make player one, it'd be like that. If you want to make player that is awesome, it'd be like that. But make the class also as simple as you can. It just has to describe what it does or what it is, and that's it. Okay, so in a player in a game, we're gonna have uh, something like in health. We're gonna have something like well, we should have private in health, right? Because hold on, I think I forgot to mention something here, but whatever. Because whenever you make variables in a class, you don't want any other code to be able to access them unless it's through controlled access points. Because if we were to do something like let's just say you write a class and you want it so that it's only accessible when like the player takes damage, right? You don't want like some random part of your code modifying the health value without you knowing. So you want to just do it through a method instead of being able to directly modify the code with the code's grubby little hands. So yeah, if we can't, so when it's private, it's only restricted to this scope. Uh, Scope is like it's a concept in Java or just in coding in general. Uh, you can think of it like little boxes, right? So the biggest box here is the public class AYLUS example because that's where all the code gets run. This another smaller box would be the public static void main, the main method, because this it goes inside here, right? So if we have something like a method out here, or a function out here, private static static boolean. Uh, we want to be able to call this because these are not because how to explain this? So the scope of this is different. They're like different boxes, right? They all fit in this big box, but you can only access a private method if it's inside you. If like for example, um, if I put a private variable here, a private int x equals 3, it's gonna yell at me because private doesn't work in here because it's kind of dumb to put private things in main. Uh, but if you put it in there, this any other code in here will be able to modify, but the code in here wouldn't be able to modify this private variable right here. And also, so like for example, this code here wouldn't be able to call on this private static boolean. Only code from here, outside here, will be able to call on it. So you can only call code. You can only call code private code if it's inside of you. if it's on the same plane or the same scope as you, or outside your scope, for example, higher up on your scope, like for example, if it was out here, if this was a private class, then this one would be able to call up to this private class. Um, it's a bit confusing, but just think of it like little boxes. You can even see the tabbing actually helps a lot. So the tabbing works. So only if something inside of you and also has a tab more to the right can you call it. If it's on the same tab level, you won't be able to call to each other. And if it's on a greater tab level or one more to the left, you also won't be able to call to it, which is really, really useful. And this just controls what can access what. So like if we try to call new funk, uh, well actually we can, because shoot, never mind. We have to, if we try to call new funk over here, we won't be able to. You can see new funk, we can't call it. Whereas if this wasn't, scratch what I just said, if it's on the same scope you could call, but if it's on a greater scope you can't. So for example, if we made this public again, and we try to call new funk, we still won't be able to because we can't call methods in here, right? All right, whatever. But you get my point, right? This just control. Oh, here, this is another way we can do it. This is probably a better way to illustrate it, actually. Um, so we can try to modify. So let's write a. We have to write out this function first. Hold up. So this is the construct. Okay, we're switching gears for a sec, just because I need to flesh out this function a bit more in order to show you what I'm talking about. I promise I'm not insane. But yeah. We need a constructor class. So how constructors are made is, or a constructor method. And remember, methods are functions just in classes. Um, and I just use them interchangeably because I'm getting confused. But technically, there's a difference. It's not big, and I don't think anyone will care. But yeah, constructor. You don't need any of the public, static, whatever stuff like that. You literally just write out the name of the function. It's also it should be case sensitive. And then this is the input. And then what constructor classes do is they're just a setup for your class. So for example, we're going to want the health to be 100. So we do this dot health to 100. Let's write an energy class or an energy function. Sorry, a variable. We're going to make this public now. Public int energy. And you don't want to set these values here. I'm not sure if it'll even let you. Actually, it will let you, but you usually don't want to do that, just because it's better to set it up in the constructor, where if you want to modify it to like get a new input, we could literally just do this int health, temp health actually, and then we do temp health. It's as easy as that, but we don't want to do that. We're gonna set energy at 100 to this dot energy equals 100. All right. And then let's also write a. So that's the constructor method basically. We can also get. Oh yeah. We also get a private string name. This is a class inside of a class. String is a class. It's inside of a class. It's pretty cool. We could get a string temp name here as the input, and then we set the input to our own name. So now when you make the class, you'll be prompted to put in an input of the name, and then that'll become the name stored in here. So yeah, these two variables are different, temp name and this dot name, but we're setting them to the same thing when the class is made. So yeah, any other setup stuff that you might want to do, maybe in like more advanced classes, you might want to like also run like, I don't know, a function that will draw pixels to the screen of the character, maybe set up key bindings there. Any maybe like start a counter for time alive. I don't know. It really the possibilities are really infinite. Depending on the usage. So how, if you, I mean, you might be asking, like, how do we access this private int health if we can't modify it by setting it, right? Well, we can use controlled access via the getter and setter methods. These are just types of methods that you can write. And so a getter method looks like this, where we do something like private, or sorry, public. This should be public because people have to access this. Public in get health. Actually, can I? Never mind. It just prompts me for the name. Anyways, so public int get health should have no input, and all it should do is return health. This dot health, and this dot is just a keyword referencing like this class. Um, like for example, how we use like string s dot equals. Uh, it's like it's a reference. Period is just a reference saying I want to get the health variable belonging to class, and in this case, this is just a keyword for the class that we're currently in. Like for example, if we want to do something like string s equals cat s dot substring, I don't know, one. We're saying we want to call the substring method that belongs to class, or that belongs to the object in this case because it's instantiated s. You can think of objects and classes like classes are the blueprints and objects are the buildings, right? You can build multiple buildings that off the same blueprint. Um, and you could change them in different ways. Like you could change the furniture around, but the underlying structure stays the same. You still have the same amount of variables, you still have the same functions, they do the same thing, but the values could be different inside of them, like the furniture of a house. So yeah, dot just means belonging to, and this is a keyword that refers to the class that we're currently in. All right, I think this is we should also write a setter method. So this is the getter method, it's spelled getter, and then this is the setter method. We're gonna do public void set health, but this time we're gonna have an input int temp health, and then this dot health equals temp health. And you can also check for something else too. You could check for other things, like if you wanted to restrict this to like admins only, you just like something like int or something like string auth key, and then like have it checked in an authentication database if you have one of those. Uh, but I mean, if you get to that point, you already know what getter and setter methods do. You already should know how to do this stuff. This is very basic things that you should do for classes, right? You should write ways to access these. But anyways, it's just good practice in this point. But like once you get to higher levels, this is something that is going to be necessary in order to control and have greater control over who accesses your code or what accesses your code. All right, private int health. All right, let's do our example. Right. Okay. So now that we have our class fully fleshed out, we can see that we can make a new player. So player p equals new player Steve. All right. So uh, I'm having a blank here. P dot so you can see we can access P dot energy, right? And we could change it to like 33, and we can system dot out print line P dot energy. This is just referencing the energy variable belonging to P, which is player, the player class that we turn into an object. But we could do this for name as well. So we could do like P dot name equals John. Wait, can we? Oh no, we made it private. Never mind. Let's put this public. There we go. So you can see, like, it just changed, right? Before, if we made this private, it says name variable, never heard of it. You see, it says name has private access in player. I can't access it. If we make it public, suddenly I can. So this is the difference between private and public in scope. This code right here is outside the scope of this. It's not inside the class. It's calling from outside, right? Because you can think of the scope like this. We have our main class, we have our main method, and then we're creating the class P in here. So this is a layer down. And then we go in here and we can magnify even more. So we have our class that we created. So this scope is the same as this scope. But then we have deeper scope, and then we have deeper scope down here. And yeah, so it just keeps going. Like if we put a for loop here, something like this, or whatever. I can't be bothered to type it out. This is even deeper scope. I can keep going and going, but you get the point. Uh, Things with lesser scope can access things with higher scope, but things with higher scope can't go in. All right. So yeah, we can code some more advanced stuff here. Like for example, we could code a take damage function. Let's not go to this actually. Let's make this all private. Oops, private. And then let's also get rid of all this. Except for this. Wait, hold up. This I want to keep. All right. Oh, shoot. Let's get this back up. Oh yeah. Okay. Come back to the. That's really nice. Oh wait, hold up. Where's my setter method? Oh, it's gone. All right. Well, yeah. You can actually one-line all this. It looks pretty nice, and it also is more compact. I kind of like it. Something like this. It's pretty neat. And it's definitely better for like if you have a bunch of variables, but you don't need to do that. Oh, okay, it went back. Oh yeah, wait, hold up. Yeah, you just do this. It'll one-line it for you. And you can magnify it. You can also do this as well. This is not too useful just because you can't even see the entire code. But I guess if you don't want to look at this, you don't have to. Um, all right, let's make a public. It doesn't have to return anything. Public void. Take damage. Uh, and damage. And then what we can do is we can actually call our own function here. We can call the set health to be this dot. We could set health the new so we could set the new health to be actually I should do this dot set health to be hold up, we're getting an error here. Why is this the case? Oh, never mind. We're just I marked it for debugging, but whatever. All right. So this dot set health equals this dot get health minus damage. So now we can do something like this. System dot out dot print line p dot get health before we take damage. Then we could do p dot take damage 30, and then we can print this out again. And then we can see it prints out 170 because we just took 30 damage. All right, that works. So basically how this works is we have an input of the amount of damage we want to take, and then we set that. So then we get the health that we have currently. We subtract damage from it, and then we set it to the new health value. And that's what we're doing, and that's how we get 100 to 70. So you could do other things too. We showed the toString function in class, kind of how you coded it. Um, but yeah, anyways, that's kind of it for today's lesson. Um, it's a lot shorter, I guess, but I think we covered a lot more content, a lot more in depth, and some quirky Java things that I didn't expect to do. And also we did some live coding. So, yeah, I guess we'll see you for the last class tomorrow, and we'll figure out what we're gonna do after that. So I feel this is a different style of like teaching. It's less slides and more discussion. So if you guys like it, then I guess we could make something work like this over school, possibly. I don't know. Yeah, all right. So I guess I'll see you guys next week.